Dear students, Sairam to all. Myself Prashanth J, Maths teacher, Sri Satya Sai Lokaseva High School, Adike. Today I shall take the 10th Maths first lesson, Arithmetic Progressions. Now let us consider some list of numbers. 1, 2, 3, 4, so on. And one more example, 2, 4, 6, 8, so on. So look at the first one, 1, 2, 3, 4, so on. So here the first term is 1. First term is 1. And the next term is obtained by adding 1 to the previous term. So remember one. So here with respect to 2, 1 is known as preceding term and 3 is known as succeeding term. With respect to 3, 2 is the preceding term and 4 is the succeeding term. Succeeding term in Kannada, Mundina Pada. Preceding term, Hindina Pada. So here with respect to 2, 1 is the preceding term and 3 is the succeeding term. So how to obtain the succeeding term? By adding 1 in this example. So in the second example, 2, 4, 6, 8, so on. With respect to 4, 2 is the preceding and 6 is the succeeding term. So how to obtain the succeeding terms? By adding 2 or by adding a fixed number to the preceding term. And each number in the list, each number is known as a term. Is known as term of a list of numbers. Now, the first term is always denoted as A1. First term is A1. What about the second term? So, this one is second term. So, second term is denoted as A2. And the third term is denoted as A3. Fourth term is denoted as A4. But my question is, how to denote the nth term? So, nth term is denoted as AN. So, the AP becomes A1, A2, A3, A4, so on up to AN. So, A1, what does it indicate? So, this is the first term. First term is A1, second term is A2, so on up to the last term or the nth term. So, nth term is AN. Next we pass on to how to check the given list of numbers are in AP or not. AP means arithmetic progression. Now let us consider some more examples. 2, 4, 6, 8, so on. And one more example, 3, 6, 9, 12, so on. Our aim is to check the given list of numbers are in AP or not, or how to define arithmetic progression, or what is arithmetic progression. So see here 2 is the first term, 4 is the second term, A1, A2, A3, A4, so on. Now how to check the given list of numbers are in AP or not? Now find the difference between the two consecutive terms. So A1, A2, A3, A4, so on. Now the difference between two consecutive terms or a term and its preceding term. A2 minus A1. Next A3, third term minus second term, A3 minus A2. Then A4 minus A3, fourth term minus third term. So in this example 2, 4, 6, 8, second term is a 4 minus a first term is a 2. So what is the difference? 4 minus 2 is a 2. And next one, A3 minus A2, third term is 6 minus second term 4. So the answer is a 2. And next A4 minus A3, fourth term is 8 minus a 6. So answer is 2. Just look at the difference. So difference is the same. And in the second example, 3, 6, 9, 12, so on. Now check whether the given list of number are in AP or not. Find the difference between the two successive terms or two consecutive terms or a term and its preceding term. So A2 minus A1. So here the A2 means second term, 6 minus 3 equal to 3. And next, A3 minus A2, 9 minus 6 equal to 3. And A4 minus A3, 12 minus 9 equal to 3. Look at the difference. What we conclude? The difference between a term and its preceding term is a constant. The difference is constant. Suppose in a list of numbers, the difference between the consecutive terms is a constant, then the given list of numbers are in AP or arithmetic progression, or a term and its preceding term. The difference between a term and its preceding term is constant, or each term is obtained by adding a fixed number, means 2, here plus 2 4, plus 2 6, plus 2 8, fixed number to the preceding term, but except the first term. So that is the arithmetic progression. I think it is clear. So how to define arithmetic progression? The difference between a term and its preceding term is a constant, then it is arithmetic progression, or each term is obtained by adding fixed number to the preceding term except the first term. So that is known as arithmetic progression. And one more thing, so the difference between a term and its preceding term is a constant, so this difference is known as common difference. So this difference is known as common difference, and it is denoted as small letter d. D means a difference. So how to find the difference? So d equal to formula A2 minus A1, second term minus first term, or A3 minus A2, or A4 minus A3 in general. So the common, how to find the common difference? D equal to A2 minus A1. And one more thing, in an AP, the first term is always denoted as A. First term, A1 means first term is nothing but A. So the first term is always denoted as A, and the common difference is denoted as D. Just to recall, what is the definition of the arithmetic progression? A term and its, the difference between a term and its preceding term is constant, then it is known as the given list of numbers are in AP. So 2, 4, 6, 8. Here the common difference is the same, then the given list of numbers are in AP. In the second example, 3, 6, 9, 12. Here also common difference is same, then the given list of numbers are in AP. Now some examples related to the arithmetic progression. 3, 6, 9, 12 are in AP because the difference between a term and its preceding term is a constant. 6 minus 3, 3. 9 minus 6, 3. So the given list of numbers are in AP. So here the first term is a 3. So here the first term is 7. Here first term is 3. Now find the common difference. So common difference or fixed number. What is arithmetic progression? An arithmetic progression is a list of numbers in which each term is obtained by adding fixed number to the preceding term. So that fixed number is known as common difference. Or an arithmetic progression is a list of numbers in which the difference between a term and its preceding term is a constant. Now find the common difference. So here is the common difference, d equal to 6 minus 3 equal to 3. So in the second example, first term a equal to 7. What about the common difference? Common difference d equal to second term 5 minus first term 7 equal to minus 2. And in the third example, so what is the common difference? D equal to 3 minus 3 equal to 0. From this example, we conclude that the common difference either be a positive number or be a negative number or it is a 0. Suppose in an AP the common difference is 0, then it is known as constant arithmetic progression. What is a constant arithmetic progression? The common difference is 0. There are three possibilities. The common difference may be positive number or negative number or 0. Now look at the examples 5, 10, 15 up to 30 and 2, 4, 6, 8, 10. In the second hand 1, 2, 3, 4 so on, and minus 3, minus 2, minus 1 so on. What is the difference between these two list of numbers? You note out the given list of numbers are in AP. Why? Because the difference is a constant. 10 minus 5, 15 minus 10, that is 5. So the constant, the given list of numbers are in AP. So here also the given list of numbers are in AP. What about 1, 2, 3, 4 are in AP. Minus 3, minus 2, minus 1 are in also AP. But what is the difference? Just look at the examples. So in the first two examples, 5, 10, 15 up to 30, the last term is given. So in the first example, the last term is 30. So here the last term is 10. How many terms are there? 1, 2, 3, 5, 10, 15, 20, 25, 30. Only 6 terms are there. So in the second example, 2, 4, 6, 8, 10, 5 terms are there. Finite number of terms are there. So such AP, so these are all in AP. So such APs are known as finite arithmetic progression. How to define finite arithmetic progression? An AP containing finite number of terms. The given list of numbers are in AP. So therefore an AP containing finite number of terms, then it is known as finite arithmetic progression. Here last term is given. So here also last term is given. If the last term is there, then it is a finite arithmetic progression. What about these two examples, 1, 2, 3, 4, so on, and minus 3, minus 2, minus 1, so on? They do not have last term. But the given list of numbers are in AP. How many terms are there? 1, 2, 3, 4, so on. Infinite number of terms. So here also infinite number of terms. So how can we define infinite arithmetic progression? So such list of numbers, such arithmetic progression are known as infinite arithmetic progression. How to define infinite arithmetic progression? An AP containing infinite number of terms, then it is known as infinite arithmetic progression. So I think it is clear. So what is the difference? Finite arithmetic progression and infinite arithmetic progression. Finite arithmetic progression means an AP containing finite number of terms, or it has a last term. So infinite AP means an AP containing infinite number of terms, then it is known as infinite arithmetic progression. So they do not have last term. Next we pass on to general form of an AP. Very important. General form of an AP. I will explain this with the help of example. So let us consider an example 3, 6, 9, 12, so on. So you know that the first term is A1, second term A2, third term A3, fourth term A4. In an AP, the succeeding term is obtained by adding a fixed number. So here plus 3, 6, plus 3, 9, plus 3, 12, or by adding fixed number. Fixed number means that is a common difference. So the first term is A and the common difference is D. Always first term is always denoted as A and the common difference is D. So how to write the first term? So general form. So first term is A1. A1 means first term A. What about the second term? Second term A2. How to obtain the second term? How to obtain the second term? By adding the fixed term. Fixed number, that is a common difference. So here A1, A2, how to get A2? By adding fixed number to the preceding term, A1, or A2 means A plus D. So this is second term. First term plus common difference, that is equal to second term. So how to get the third term? So third term A3. A3 means second term plus common difference. So here 9 means a third term. How to get the third term? 6 plus 3. 3 means a common difference. So 6 plus 3 means that is second term A plus D equal to A plus D, that is a 2D. So this is the second term. A first term, second term A plus D, third term A plus 2D. What about the fourth term? A4 equal to third term plus common difference. So what is the third term? A plus 2D plus common difference D. So equal to A plus 3D. And what about the fifth term? Fifth term is fourth term plus common difference. A plus 3D plus D equal to A plus 4D and so on. So therefore, the general form of AP, first term A, second term A plus D, third term A plus 2D, fourth term A plus 3D, so on. So this is the general form of the AP. Very important. So general form of AP, A plus D, A plus 2D, A plus 3D, so on. How to obtain the succeeding term? By adding the fixed term, fixed number to the preceding term. So fixed number is known as a common difference. So the general form A plus D, A plus 2D, A plus 3D, so on. Next, our aim is to find the nth term or the last term. How to find the nth term or the last term of the AP? So the next concept is nth term of an AP. Nth term or the general term of an AP. Just recall the general form of an AP. What is the general form? A plus D, A plus 2D, A plus 3D, so on. Now next, what is the nth term or the general term? So let A1, A2, A3, so on, AN are in AP. What is the first term? First term is A. What is the common difference? A2 minus A1 equal to A3 minus A2 equal to A4 minus A3 equal to dash dash, so on. What is the last term? Last term is AN minus what is the preceding term of AN? Just think. What is the preceding term of AN? Preceding term of AN is AN minus 1. So which is equal to D. So this is a common difference. A is the first term and D is the common difference. Now the first term A1. So A1 equal to A. A1 equal to A, or we can write it as A plus 0 into D, because in an AP each term is obtained by adding a fixed number to the preceding term except the first term. Except the first term means the first term there is no common difference. So common difference is 0. So A plus 0 into D. What is the value 0 into D? 0 into D is 0. So A plus 0, A. Or we can write it as A plus first term means 1 minus 1 into D. 1 minus 1, 0. 0 into D, 0. A plus 0, A. What about the second term? A2. So A2 means by adding fixed term, fixed number to the preceding term. First term A1 plus D. First term plus common difference equal to A2. Or first term is A plus D equal to, how can you write A plus D? So A plus, that is second term, 2 minus 1 into D. 2 minus 1, 1. 1 into D, D. That is A plus D. A plus D is the second term. Now third term. So A3. So A3 equal to second term plus common difference. Second term plus common difference. So what is the second term? Second term is A plus D plus common difference plus D. A plus 2D equal to, or A plus third term, that is 3 minus 1 into D. So 3 minus 1, 2. 2 into D, 2D. So A plus 2D. That is A plus 2D is the third term. So the fourth term A4. A4 equal to third term plus common difference. So third term is A plus 2D plus D equal to A plus 3D. A plus 3D is the fourth term, or equal to A plus 4 minus 1 into D. 4 minus 1, 3. 3 into D, 3D. That is A plus 3D. Now similarly, so first term, second term, third term, fourth term, fifth term, so on. So similarly, how can we write the nth term? Nth term is denoted as an, or the last term. Sometimes it is also denoted as last term as L. But in general, last term or the nth term or the general term is denoted as an. So what is an? An means A plus 4, fourth term is 4 minus 1 into D. Fifth term 5 minus 1 into D. Sixth term A plus 6 minus 1 into D. What about nth term? Nth term A plus n minus 1 into D. So this is the general term of an AP. General term or the nth term of an AP. So an equal to A plus n minus 1 into D. So this is the formula to find the nth term of an AP. What is the formula? An equal to A plus n minus 1 into D. Now A is the first term. D, common difference. N, number of terms. And what about An? An means nth term. Now what is the general form of an AP? General form of an AP, A plus D, A plus 2D, A plus 3D, so on. What is the last term? Last term or the nth term, A plus n minus 1 into D. So this is the general form of an AP. A first term, second term, third term, fourth term, nth term. A plus D, A plus 2D, so on. A plus n minus 1 into D. What is the formula to find the nth term of an AP? Nth term of an AP is An equal to A plus n minus 1 into D. An denotes nth term. Now some examples related to arithmetic progressions. So in the following, check whether they are AP or not. Go through the questions. In the following, check whether they are AP or not. How to check the given list of numbers AP or not? Just to find the difference between any two terms. So in the first example, 4, 10, 16, 22, so on. A2 minus A1. So A2, 10 minus 4 equal to 6. And A3 minus A2, A3 16 minus 10 equal to 6. A4 minus A3 equal to 22 minus 16 equal to 6. What about the common difference? Suppose the common difference is the same, then the given list of numbers are in AP. So our conclusion, common difference is the same, they are in AP. Or the given list of numbers are in AP. So the second example, 2, 4, 8, 16, so on. Now find the difference between the two consecutive terms. So A2 minus A1. A2 minus A1, 4 minus 2 equal to 2. Next, A3 minus A2. So A3, 8 minus 4. 8 minus 4 equal to 4. Just look at the common difference. Common difference is not equal. So therefore our conclusion, A3 minus A2 is not equal to A2 minus A1. So our conclusion, they are not in AP. They are not in AP. Students, we will stop today's class and in the next class solve some more problems. Thank you one and all.